Hi again. We're on Chapter 5, Lesson 7, Graphing on the Coordinate Plane. Please turn to page 403. Let's look at the real-world link. Alright. The real-world link, scavenger hunt. Maria hid the clues to a scavenger hunt for her hiking club. Use the map to show where she hid the clues. Identify the location of each clue. So, the first clue says, the first clue is hidden near a tree. What ordered pair describes its location? Let's just do a quick review. We know that an ordered pair is listed x, y. We know that the vertical axis is the y-axis and the horizontal axis is the x-axis. I also want to talk about the origin or center. The center of your coordinate plane is called the origin. It is located at 0, 0. Now, what I would like you to do is to complete all of these on your own and then come back and see if you have it correct. So I'm going to pause you. Please complete the 6 clues and then come back and we'll see if you got the right answers. Near a tree. What ordered pair is the tree? Did you notice that the increments were every 2? Starting at the origin, going over, we know that the tree is located at 4, 2. Maria hid the next clue at a location that's reflected across the y-axis. That would put her at the library. She then walks 3 blocks east and 2 blocks north to place the next clue. And remember, again, each one of these are 2, so we're going to go across the whole block and then half a block. Okay, that's 3 and up 2. That puts her at the soccer field. The next clue is at a location reflected across the x-axis. So now we're at the soccer field. We've got to go across the x-axis. That puts us at the playground. Maria hid the next clue under a rock by the lake. How many blocks east did she walk to get to the lake? So here we are. Remember, each one again is 2. So she's here at midway between. So that's 1, 2, 3, 4, 5, 6. So she walked 6 blocks east. And the last clue tells the hikers to walk 5 blocks north and 3 blocks east to find the prize. So we're going to go 5 blocks, 2, 4, 5, and 3 east. That puts us at 8, 1. Did you get these answers? If so, turn the page. Okay, so now we're going to graph ordered pairs. We're going to graph point M at -3, 5. So let's recap what we learned. -3 means we're going left along the x-axis and up on the y. Over 3 to the left and up 5. Did that make sense to you? Again, remember, we always run before we jump. So we always move along the x-axis first, followed by the y-axis. Let's look at example number 2. In example number 2, we need to graph point N at -2.5 and -3.5. Notice that I can do increments on my graph. I don't have to have integers or whole in appearance points. I can have parts also. So We start at the origin. Remember, the origin is 0, 0. We're going to go to negative 2.5. That means, again, we're going left. And then we're going to go down. So go over, 2.5 to the left, and down, 3.5. That puts us at n, so that's how we graph that. Get it, got it, go. Put it on pause. See you in a minute. Does your coordinate plane look like mine? Let's talk about C and D briefly. Again, we can write numbers in fraction form and in decimal form. We know that negative 1/2 can also be written as negative 0.5, comma, negative 2.5. And S can be written as 4.5, comma, 1. Again, remember that fractions and decimals are the same number. They're just written in different forms. Turn the page. Remember yesterday when we talked about reflections on the coordinate plane. You can graph those very easy. Remembering again that reflecting across the x and the y axis. In the x-axis, the x-coordinate will be the same, and the y will be opposite. Conversely, on the y-axis, the y will be the same, and the x will be opposite. So that's a lot of writing. Let's come over here and write this down so that we can get this correct. So, when we're reflecting across the x-axis, the x stays the same and the y is opposite. In other words, if it's positive, it becomes negative. If it's negative, it becomes positive. And on the y-axis, the x is opposite and the y is the same. Let's look at example number 3. All right, in example number 3, graph A, which is at 2, negative 4. So we first have to find 2, negative 4. From the origin, we go 2 over, down 4. So here we are at A. Then graph its reflection across the y-axis. Now, let's talk about points and reflections. The initial point is called A. When we reflect it, the new point is called A prime. So, what did we learn? Let's remember, we're going across the x-axis. The point is at 2, negative 4. We know that the x stays the same and the y is opposite. Therefore, our prime point, or A prime, would be at 2, 4. There we are. Let's look at example number 4. All right, in example number 4, graph B, which is at negative 1.5 and 3. So we first have to go over to negative 1, negative 1.5, and up 3. Here we are. So B is located at negative 1.5 and 3. We now want to reflect across the y-axis, so the y-axis. And we remember that the y-axis, the x is opposite and the y stays the same. So B is at negative 5, sorry, let me erase that, hold on. So point B is at negative 1.5, comma 3. And B prime, let's see, we have to have the opposite of negative 1.5. That would be 1.5. And then the y stays the same. So again, reflecting across, that puts us at 1.5 and up 3. Get it, got it, go. Okay, look at yours. Does it match mine? C was across the x-axis. So C, let's use a different color. C goes across the x-axis. And then D went across the y-axis. Does yours look like mine? If so, turn the page. Mr. Martin is using a coordinate plane to design a logo. He drafts points at 2, 4, 2, negative 2, and he reflects 2, negative 2 across the y. Then he reflects the other point across the x-axis. What kind of figure did he just make? So, we start at 2, 4. 2, 4 puts us up here. Then we're at 2, negative 2. This little red dot right here. We reflect 2, negative 2, 2, negative 2, that's down here, across the x-axis. Oh, sorry. Let's read this one more time. He reflects 2, negative 2, across the y-axis. Okay, that makes more sense to me. All right, 2, negative 2 across the y-axis. This is the y. And now he's on that green dot. What kind of figure? Well, we know it's a quadrilateral with one set of parallel lines. That makes it a trapezoid. Get it, got it, go. Did you draw a rectangle? If so, you're right. Now I want to ask an interesting question. What if all the points were the same number and the opposite? So instead of negative 3, 4, if it was negative 3, 3, that would put him here. Reflected across here, reflected across here, reflected across here. What kind of shape is the red one? You guessed it, it's a square. Now, please understand that this figure is not to scale, but it's across 6, down 6, across 6, and up 6. Great! Get it, got it, go! You should now be doing the guided practice. Pause the video. Do you get it? Pause. In number 1, did you draw a triangle? If so, you're correct. And then how does it help you draw geometric figures? Well, we know that the points on a figure are called vertices. A single point is a vertex. More than one are points, which are vertices. Thank you for listening to my lesson.